Right. Okay. Sorry, there was a slight change to what I'd chosen to present here. So rather than Bob elective care, this is about ThamesValley mental care and critical care access. So very similar, showing the same kind of capabilities of our software and our products at the moment. Just quick introduction. My name is Rich Sanders. I've been with SCW Geospatial about 6 years now. I'm a principal analyst, so right in the middle of the team, developing lots of solutions, such as the IMS flu map and a lot of work around elective care and patient activity, which is what I'm going to show you now. So this piece of work focuses on Thames Valley, particularly as you can see the kind of Oxfordshire area. So the map you can see in front of you shows you 3 ICBs, Milton Keynes, Bob and Frimley, with the map clearly focusing on the sort of Oxfordshire area. So what we were asked to do here was come up with a baselining exercise. So it's looking at mental health and critical care access. So specifically 111 calls and 999 calls. So they wanted a baseline. They wanted to know where the calls were coming from, what was the cause of most of the calls, how are they being dealt with, what does the landscape look like in terms of population deprivation, that sort of thing. We were given some data, which is a new type of data set for us. We hadn't received this at this level before. We immediately started exploring and found a really interesting data set. This is the application we've come up with for our customers. So I'm just going to scroll the screen away a little bit and focus first on the 111 data, which is, I've chosen a kind of red theme for that. 999 data will come later, which I'm using a purple theme for. So what you can see here is it's a product we use very often. It's called a heat map, or a choropleth is the sort of technical term for it. And what it's showing is trying to use instinctive colours. So what these shapes you can see are postcode districts. So if you live anywhere near the Oxford area or visited, you'll probably know what these postcode districts was. So we just quickly turn on the labels. You can see the districts are things like, OX1, OX2, OX3 in the centre of Oxford, so fresh, or around Reading, RG1, RG6, RG5 postcodes, and then around Aylesbury, the HP postcodes. So this is displaying data against postcode districts, so kind of quite a familiar area. And what the data is showing us is the heat map is, let's bring up the legend, basically the darker the colour, the more calls for 111 mental health related calls are coming from that area. This is a theme that we use over and over again, but typically darker equals more intense, equals perhaps more or a worse situation. A lighter colour equals sort of less intense, lower activity, or perhaps a better situation. So, less deprived areas, that sort of thing. So what this map is showing you is it's reflecting the higher call volumes around the conurbations. So these darker colours around Oxford, Abingdon, Maidenhead, Reading. So it's immediately showing you where calls are coming from. I'll just turn those labels off because they're a little bit distracting. For every area, you can the data is interactive, so you can click on this area. So this is OX3. Tells you the exact number of calls, so 1,010 in the time period. It gives you a little breakdown of the reason for calls. So, and you can click on this for any of the areas. At the same time, you've got infographics up at the side. So here on the left, we've got what's the reason for the calls, and it's giving you a donut chart, almost like a pie chart with a hole in the middle, showing, like, sadly, almost 50% of the calls there related to suicide, many other with general mental health issues, smaller wedge, so about 7% for behaviour change, and a much smaller wedge, about 1.5% for alcohol and substance abuse. But it's all broken down by the most popular categories for reasons for the calls. It's also showing you what the call outcome is, and by outcome here we mean which service dealt with it. So you can see a large section was dealt with by accident emergency department, so 43%, so almost half. About 30%, so about a third, was dealt with by the primary care service, and then smaller sections by other non-clinical or ambulance services. So this gives you the overall picture, but this map also features a filter up in the top left, so you can sort of delve into the data, very much as you'd be able to do if you had a spreadsheet with categories and a filter at the top. So what we can do is delve into what the reason for the call is. So if we pick one of the more popular ones, like mental health issues, click on that, immediately the whole map redraws. So if there's only a subset of the data, mental health, rather than all of them, the map becomes a bit lighter, and it shows you on the map, it shows you the pattern of distribution of calls from mental health issues. So again, quite a lot in Oxford and Abingdon to the south, Reading, Maidenhead, but it shows you that the slightly different distribution for these. The infographics immediately update. So this top donut chart is all mental health issues, but it shows you that lots of them, much larger proportion. So almost 2/3 are dealt with by primary care then. Similarly, we could change it to suicide. The map updates, shows you the distribution on the map, and suddenly many more are dealt with by A&E and ambulances. So this immediately gives you an idea of the landscape. You can also filter the call by the call outcome. So if we set reasonable call to all and say, let's have a map of what's being dealt with by primary care in the area. This donut chart changes to all primary care. And then in terms of the reasons for the calls, the largest one is mental health issues. Or what about what is causing busyness with A&E? Redraw that. So suicide is a large proportion of that. So the goal of this was giving you a baseline. Where are the 111 calls coming from? Which services are they using, and how are they distributed? So it was the first part of the exercise. Seems to have gone down well. We'll now focus on the 999 data. So I'll just squirrel away the 111 dashboards and extend the 999 ones a little bit. I'll pick up the layer control. I'll take off the 111 call volume, and I'll bring up the equivalent 999 data. So just let that redraw a second. Okay, and again, you've got a very similar picture. So here we're using a sort of yellow to purple color theme. And if we look at the legend, again, it's the same thing, of a darker color. So the darkest purple colors equal the greatest volume of calls, and the lighter color equals the fewest calls. So again, we can see a concentration of calls around Oxford, around Reading, around Maidenhead. You'll notice that the polygons here are a lot smaller. These are called lower super app areas. So rather than a postcode district, which is, you'd only get like 3 or 4 for a town centre, there's much more detail here. So this was a richer data set. We were sent 999 data. So we can see a lot more detail in the centre of Oxford. Again, you can click on an individual LSOA and see the exact number of calls and a little breakdown of what the reason for the calls was. So very similar to the 111 data, but just with a little bit more detail. So LSOAs aren't as easy to recognise, perhaps, in terms of their names. They've all got sort of funny codes like E106903. No one understands what the LSOA code is. But the advantage with them is that lots of data is published at LSOA level. They'll nest nicely into local authority district boundaries, and also NHS boundaries like ICB boundaries, PCN boundaries, and other data is published at these geographies, so like population density, the number of people in different ethnic groups, deprivation, transport access. Tons of data is available at this data, so there are big advantages to using LSOAs. Another way in which this data is richer is that, as well as knowing where people are coming from, we also know where they were dealt with. So we've also got patient destinations, and these are the hospitals and clinics where the calls were dealt with. So, and again, these are graduated symbols. So a large purple blob here indicates, so this is the John Radcliffe Hospital, which dealt with a large number of calls, up sort of 3,500, or there's another large hospital in Reading, the Royal Berkshire Hospital. So this shows you where they're coming from. Immediately, you probably want to think, where are the calls starting off? Where do people live? Where are they going to? And we can visualize this using spider diagrams. So some people absolutely love these. They find it really brings the map to life, shows you where the sort of patient flows are effectively happening. For other people, it's just a bit of a load of pickup sticks obscuring things. So, depending on what your point of view is, how the visualizations work for you, you can customize the map to make it work for you. So I'll take the spiders off for the time being, but you can appreciate these do give you a good idea of sort of where the activity is coming from, where it's going to. So I'll take it again. I clicked on the wrong thing there. Action journeys, click there. Okay, so as before, there are always infographics active. So what we've got here is what are the 999 calls by chief complaint. So what's the reason for the call? So we've got categories like overdoses, psychological mental health, psychosocial issues, or substance abuse is a smaller wedge of the pie there. And again, we've got filtering technology, so you can click on a single one. So if we click on psychosocial behaviour change, apply the filter. Just like before, the map is completely redrawn, so you get a different heat map, you get different graduated points showing where everything's dealt with, and a different pie chart as well. So you can sort of delve into the data. Well, let's look, ETOH is ethanol, so these are alcohol problems, very, very small volumes of calls there. Let's look at substance abuse, again, very small volumes. Psychiatric. So yeah, the map can be redrawn to show you what's happening for each of the categories across the data set. Let me just take it back to all again. So a final thing we tried with this was people are always very interested in what the relationship is between what we'd call the project data here, so the 111 and 999 calls, and other factors like ethnicity, deprivation. So we have got these added to the map, so you can bring up index of multiple deprivation here. So again, same sort of thing, dark color equals more deprived areas. And you can sort of peruse the two data sets one after the other, so you can look at how the two interact. So you can fade one out and fade the other in. So there's deprivation, there's 999 calls. So you can try and spot patterns using that. But we tried to go another step further with this project. Clear that. So what we did, as I said before, if you use data at LSOA level, you've got other data that you can add to it. So here we looked at how deprivation varied with 999 calls, and that's what this graph is telling you here. So if you first focus, sorry, just click to pop up. First focus on the grey bars here. What this is showing you is these figures from 1 to 10 are IND decile. So 1 is the most deprived areas, 10 is the least deprived areas, the most affluent areas. The study area around here, particularly Oxfordshire, it doesn't have many people in the most deprived areas of 1 and 2, so the graphs are quite small here. There's quite a lot of people in the more affluent areas. So what we presumed here was, imagine if all the calls just came from across the map, from, they just followed the distribution of the population and weren't dependent on how deprived people were or their proximity to services, anything like that. So that's what these grey bars show. So this is showing you how many calls you'd expect per LSOA if everything was distributed sort of evenly across the study area, the same way that the population is. You'd expect a lot of calls from people in IMD decile 10 because there's just lots of people there, lots in 9, lots in 8, and then fewer and fewer as you get down to 1. Then what the pink bars are showing you is what we actually observed from the data. So this is sort of observed by comparison with expected. And what this shows you here is that IMD decile 10, you're actually getting far fewer calls, like not quite half, but maybe sort of 2/3 by comparison with what you'd expect based on how many people live there. Similar for 9, there's fewer calls than you would expect based on just the distribution of the population. As I said, there aren't many people living in IMD decile 1, but in 2 and 3 and 4, you are getting what looks like quite a few more calls in those more deprived areas by comparison with just how many people live there. So, this isn't stats, I'm not claiming causality, but this gives you a really, really easy one-hit way of perusing the two data sets next to each other. And we could take this further, we could take it on to another team to do some statistics on it, see if there's a significant relationship. But we feel this is a really good way of just getting your head around the data and exploring what's going on, because this is a baselining exercise after all. It's about looking at the data and working out what the situation is, and then can we make any changes? Can we do things better? Can we make our NHS a more efficient organisation, a more efficient machine? Okay, that's the end of my presentation. I realised it was quite dense. Please, if anyone has any questions, let me know and I'll do my best to answer them.